Good afternoon, friends. Now we are discussing on types of fluids. We are having the following types of fluids. Ideal fluid. So it is the fluid when it cannot be compressed or it is not having any viscosity. But it is the imaginary one. We don't have any such fluids in this world. All the fluids what we are seeing ever in our daily life are having some compressibility and having some viscosity. So an ideal fluid is the imaginary fluid. So next one is the real fluid. So real fluid means the fluid which is having a viscosity. All the fluids are real fluids only. Then Newtonian fluids. When the fluid obeys Newton's law of viscosity, so such fluids will be called as Newtonian fluids. Now, non-Newtonian fluids. When the fluid does not obey Newton's law of viscosity, they are non-Newtonian fluids. Then ideal plastic fluid. When the shear stress is proportional to the velocity gradient and the shear stress is more than the yield value, so it is called as the ideal plastic fluid. So this is the ideal plastic fluid. My Newtonian fluid is the one as the shear stress increases, shear strain also increases. But the plastic fluid, so once the stress crosses certain limit, so then only there will be increase in the strain. So the shear stress is proportional to velocity gradient and shear stress is more than the yield value. So that is from here to here we have the yield value. So my shear stress is more than my yield value. Then incompressible fluid, when the density of the fluid does not change, that is if you are able to compress the fluid means the density of the fluid changes, but if you cannot compress the fluid means density of the fluid does not change. When the density of the fluid does not change with the application of external force, such fluids are called as incompressible fluids. So compressible fluids are opposite to that. That is, density of the fluid changes with the application of the external force. So here in the graph, all the fluids are shown here. Ideal fluid is on x-axis, having no viscosity, no shear stress coming into picture. Then Bingham plastic fluid. It is the viscoplastic material that behaves as the rigid body at the low stresses but flows as a viscous fluid at the high stress. So dilatant fluids. They are shear thickening fluids. They are the liquids or solutions whose viscosity increases as the stress is applied here. So that is dilatant fluid. So that is shown here. That is viscosity increases as the stress increases. Uh, they are an example of non-Newtonian fluids, that is which do not obey Newton's law of viscosity, as they don't have the linear relationship between the shear stress versus shear rate. That is particular about Newtonian fluids. That is, shear stress is proportional to the shear rate. But this dilatant fluids, so there is no linear relationship between the shear stress and the shear rate. Then pseudoplastic fluids, they are the shear thinning fluids opposite to this dilatant fluids. So here the viscosity of these fluids decreases as the shear rate increases. So you can see that pseudoplastic. So there is a fall in the value of uh, the viscosity. Then types of the fluid flow. The fluid flow is having all kinds of aspects: steady or unsteady flow, compressible or incompressible flow, viscous or non-viscous flow, rotational or irrotational flow, to name few. Some of these characteristics will reflect the properties of the fluid itself, and others will focus on how the fluid is moving. Steady or unsteady flow. Here the fluid flow can be steady or unsteady depending on the fluid's velocity. So steady flow. In steady fluid flow, the velocity of the fluid is constant at any point of time. So velocity here if you take so with respect to the time, so it is 0. So the pressure at any point of time, so that is there is no change in pressure, so the pressure remains the same and density also remains the same with respect to time. So but the flow will be called as unsteady when the fluid's velocity will differ between any 2 points. So here it is shown the velocity, pressure and density. So at any point of time will not be the same. They are changing from time to time. Viscous or non-viscous flow. Liquids flow can be called as non-viscous flow. Then uniform flow. It is the type of the fluid flow in which velocity of the flow at any given time does not change with respect to the space here. So that is T is constant. So that is we are not measuring the flow with respect to the time. So in the length of the direction, so with respect to the space, so it is 0. The velocity is 0. A non-uniform flow is the one in which the velocity of the flow at any given time changes with respect to the space. So T is constant. So that is velocity is changing. That is if you take the velocity at that particular time at point 1. Now, for the same time, if I measure the velocity at given point 2, the velocity at point 1 is not the same as the velocity at point 2 in case of non-uniform flow. Then laminar and turbulent flow. Laminar and turbulent flow in a pipe flow is characterized based on Reynolds number. So here laminar flow and turbulent flow are shown. So laminar flow is the one in which the fluid particles move along a well-defined streamlines or the paths. Such streamlines are straight and parallel to each other. So they are moving in laminas. That's why the name came as laminar flow. Turbulent flow. So it is the type of flow in which the fluid particles move in a zigzag manner. So the movement in zigzag manner results in high turbulence. So that's why the name came as turbulent flow. Thank you. Now we have compressible and incompressible flows. A compressible flow is the type of flow in which the density of the fluid changes from one point to other point. So whatever density we have at point 1 is not the same as the density at point 2. So this means that density is not constant. So incompressible flow is the one in which the density of the fluid remains same from one point to another point. So liquids are generally incompressible and gases are compressible. So here density is equal to constant. Now rotational and irrotational flow, a type of flow in which the fluid particle rotate about its own axis while flowing along the streamline. So it's called rotational flow. So here we can see the fluid particle is rotating about its own axis. If the fluid particle while flowing along the streamline do not rotate about its own axis, see this sketch. So the position of the fluid particle is same along the streamline. So it is the case of irrotational flow. then 1D, 2D, and 3D flow. So one dimensional flow, it is the flow in which the flow parameters such as velocity is expressed as a function of time and uh, space, one space coordinate. So here we are taking the velocity as the function of x and y. So here my velocity components along y-axis and z-axis are ignored. So v is 0, w is 0. So we are taking the velocity in x-axis. So it is shown as the function of time and one space coordinate. Now, so if the velocity is shown as the two space coordinates. Here we are taking the x and the y axis. U is f of xy and v is g of xy. The third coordinate, that is z axis w, is ignored. Then three-dimensional flow. We are taking all the components of velocity in three directions, x, y, and z. So u, v, and w are shown. Thank you.